Santa Teresa Laboratory presents number 1 in a series of Meet the Developer presentations. Dr. John Ehrman, meet the man behind your high-level assembler.
Hello, I'm John Ehrman from IBM's Santa Teresa Programming Laboratory in San Jose, California. I'd like to take a few minutes to describe for you some of the benefits and features of IBM's new high-level assembler. After that, we'll take a short break, and then I'll come back and explore with you some of the new features in a bit more detail. So first of all, let me explain why it is that IBM produced a new assembler for you. We have found in discussions with customers that many of them have large suites of applications written in assembler language that they are still developing and maintaining. Also, we have found from these discussions that many of the programmers that they have who work on developing and maintaining these applications are harder to find and harder to train. So it's important for companies to get the maximum productivity from the people with those increasingly rare skills. And third, we have had a continuing stream of requirements for assembler enhancements from our customers. So what we have done is to develop a new high-level assembler for you that satisfies many of those customer requests, and it is targeted to satisfying the needs of developers and maintainers of assembler applications. Finally, one of the benefits is that it is a single assembler which runs across all three of IBM's mainline operating systems for the System 370, 390 series of machines, so that you no longer have to worry about the differences of assemblers across those environments. Let's take a look at what some of the benefits of this new high-level assembler will be for you. First of all, the new assembler contains many new and extended cross-reference capabilities for all of the elements of your programs. You'll find that this will save you an enormous amount of time in maintaining large applications because it will help you to tie the pieces together. Secondly, there have been many usability enhancements which we believe will save lots of time and energy that are required to analyze and maintain those applications. Third, we've added a bunch of new diagnostics and improved some of the existing ones, and we believe that this will help to improve the quality and the accuracy of the programs that you generate using this new assembler. Fourth, there are many language enhancements which will make it easier to write applications. Some of them, and this is hard to believe, but we'll explain this in the second part, can actually improve the efficiency of your assembler applications so that you should be able to deliver your applications more rapidly, with higher quality, and with greater reliability. And finally, there are many new options which will help you to control the assembler development process. There are two other major categories of benefits from this new assembler. The first is a group that I call tool and environment support. And the first of those is that the assembler can produce what we call an assembler data file, which contains information about every aspect of the program being assembled and the assembly environment. And the key benefit of this feature is that you no longer have to rely on auxiliary tools that scan listings, source files, JCL, and the like. All the information is now in this file. And secondly, there are optional exits for all of your files so that you can control and monitor the flow of information into and out of the assembler. Finally, there are a number of enhancements that will save on system resources. And of course, one of the benefits of all these new features in the assembler is that we expect that you will need fewer assemblies to get your jobs done. So finally, to summarize this portion of the presentation, the new high-level assembler provides advanced assembler technology. It will support your critical applications. It will help to maximize the productivity of those people in your organizations who have those rare and critical skills. And third, it will help to integrate this new assembler into the tool and development environments that you already have. The many new features of the assembler include language enhancements, usability enhancements, many new diagnostic capabilities, and virtually every area of the assembler you'll find improvements. And we expect that that will lead to cost savings for you in terms of faster development cycles, more reliable applications, and of course, more productive programmers for you. We'll now take a short break, and I'll come back in a little bit to give you an overview of some of the facilities that I've just described. Welcome back. I'd like to tell you now about some of the actual technical features of the new high-level assembler, and I think you'll find that these are the things that make it a really exciting product. First of all, let me tell you about some of the new development support functions that the high-level assembler provides. The first one is what we call the macro and copy code source catalog. What this provides for you is for every element brought from the library, either a macro or a copy segment, information about the data set, the member name, and the volume on which the library was found. This allows you to have a precise identification of where every element of your program came from in terms of the library. Similar information is provided for the input data sets in the summary statistics, so that you now have a way of tracking where every source element of the program came from. In the DSEC definition XREF, the length of every DSEC, its starting statement, and its relocation ID are provided. The relocation ID is the same as the ESD ID for external symbols. This information is particularly useful in that the ordinary symbol cross-reference now gives you, in addition to the usual information, the relocation ID, so that you can tell exactly which control section, either an ordinary or a dummy control section, each symbol belongs. Other information is also provided in the symbol cross-reference that is new, including, for example, the fact that references are flagged if the assembler detects those as either modification references, for example, the target register of a load or the target symbol for a store, or if the symbol references a branch target. This will help you to determine in large assemblies who is doing modifications to what named element. The using map is a complete summary at the end of the assembly of all the using and drop activity in the program. This will help you a lot to determine how addresses are resolved in your programs. The RSEC statement has been added to allow you to specify that a particular control section should be reentrant or read-only. This means that you can build a program that contains a mixture of non-reentrant and reentrant code. The rent option still specifies that the entire assembly should be checked for reenterability, but with RSEC you can now specify reenterability checking on a control section basis. The P-control option is a very useful debugging option. If you have a large assembly that contains lots of print off, print no data, print no gen statements that are hiding information that you need to find in order to debug a program, the P-control option will allow you to override those from outside the source code. So you no longer have to make a copy of the source statements, hunt down all those print control statements, change them, iterate again, make further changes until you found them all, and then assemble. With this option, all you have to do is to assemble once, and you get a complete assembly where everything is visible. I've mentioned the summary statistics containing input about information about the input files. It also summarizes the version and level of the assembler, the date, the I/O activity, many other things, including the return code. The compat option addresses two language compatibility issues that I'll describe in a moment. Finally, the libmac option is another useful debugging option. If you have a library macro that you suspect has a bug in it that only shows up when you invoke it with certain parameters, normally you get a very terse and sometimes cryptic diagnostic from that. By specifying the libmac option, the source statements for that macro will appear in your program, and the diagnostics associated with the error will be much more precise than they were with previous assemblers. Another set of capabilities in the new assembler is what we call tool and environment support. The first of these is the optional sys data file. If you specify the option that requests this, the assembler will produce a side file that contains information about every aspect of the assembly, what all of the input data sets are, what the source records are, what the options are, the date and the time, the version of the assembly, every source record, every error record, the symbol table, cross-reference information, essentially a full characterization of every aspect of the assembly. This means that you will no longer have to use tools that scan listings, scan JCL, or scan source files. The second group of capabilities that help to integrate the assembler into your development environments are the I/O exits, so that, for example, you could use the source and macro and copy exits to determine where all of your records are coming from. You could, for example, couple the assembler to a librarian without the need to write intermediate temporary files. Also, you could use this exit, for example, to track macro and copy file usage. The listing exit can be used to add information, for example, like register usage tags to the right-hand side of the listing. The punch and object file exits could be used, for example, to insert linkage editor control cards into the output stream. And the assembler data file exit can be used, for example, to monitor the SysA data records and to extract information about some particular aspect of the assembly that is interesting to you. We've added an exit control statement which will allow you from within the program to provide information to the exit routines to control their behavior if you want to do that. The ASA print option allows you to specify that the assembler should use ASA carriage control characters rather than today's machine carriage control characters, and this will help to integrate the assembler into those environments with other products that use ASA carriage controls. And finally, the longer print line records are tolerated by the assembler so that you can specify them to be larger if you like, and this will give you room to add more information, for example, on an exit or in a post processor. Now I'd like to explain to you some of the new language features in the high-level assembler. First of all, the assembler will now accept mixed case inputs so that you can get rid of your 029 key punches. That is under option control, so that if it's important to you to have the assembler behave the way previous assemblers have, you can specify the compat option. This also means that symbols and operation codes may be in mixed case. They are treated internally in the assembler as though they are uppercase. Secondly, blank input records may be used to improve readability. They're simply treated as though they're a space statement. The third group of extensions here are quite major, and they give you a great deal of flexibility and power. These are called dependent and labeled usings, and I'll show you an example of those in a moment. Labeled usings let you address multiple instances of a dummy control section at a time. This you could not do with previous assemblers. Secondly, dependent usings allow you to map multiple DSECs, independent DSECs, with a single base register. And of course, you can combine those by using labeled dependent usings. There are also some new using diagnostics, and I'll give you an example of those. And of course, there are extensions to the drop statement corresponding to these new using options. So first, let's take a look at what labeled usings do for you. In this example, I suppose that I have three little control blocks that are described by a DSEC named block. Now, if these were ordinary using statements, only the last one would be effective because register 5 is the higher numbered register. However, the presence of a label in the name field of these indicates that these are labeled usings, and these labels are used to qualify the symbols in statements like this, so that I can now refer to a symbol like this that occurs in two different DSECs without having to calculate manually a symbolic offset. And you can see from the color coding here that I'm able to refer to instances in these different control blocks using the same symbolic names in each. So that's an example of how you use labeled usings. Dependent usings allow you to overlay and merge DSECs in such a way that they're addressed with a single register. And in this little example, I've supposed three little control blocks here, all of which will fit into one 4K block of storage. So if I get the storage for that and anchor it with register 7, I now issue an ordinary using statement specifying register 7 for the first control block. This using statement for the second control block specifies a relocatable operand instead of a register here, and this means to anchor this control block at that address. And it's this relocatable operand that distinguishes this as a dependent using. This means that then I can make symbolic references to the fields in those three dsects, and they will all be resolved with a single register. You can combine the benefits of labeled and dependent usings, as in this example, where we have a small program that uses a single base register. It contains two control blocks of identical structure with these names. I now issue two labeled usings that map those two control blocks and which are overlaid on the control blocks at their respective addresses. So these are dependent labeled usings. And I can now refer to the fields in those two using symbolic references without having to manually calculate a displacement and a register number. To illustrate some of the new using diagnostics, in this little simple program statement, I start off issuing a using statement with a base address of star and register 10. The following one has the same base address but a higher numbered register, which means that the previous using now has become inactive because the assembler always uses the highest numbered register for a given displacement. Previous assemblers did not give you a diagnostic to tell you that, and you could find yourself in a situation where very difficult bugs could be caused by the fact that you believe that one or the other of these was active. Similarly, you may have thought that this using statement, because it was subsequent to this one, overrode it, but it doesn't because it has a lower numbered register. And again, the assembler will warn you of that condition. Finally, we've added a diagnostic that is of considerable help if you're trying to maintain very large programs. This will help to tell you if you're running out of addressability either for code or data. If a calculated displacement exceeds a limit that you've specified, then the assembler will give you a warning to tell you that you're running out of addressability. The final using diagnostic is one that will help you to map those cases where you may be using a non-zero absolute or relocatable expression as a base address, but with register 0, which, as you'll remember, can only be used as a base address for addresses beginning at 0. So that if this operand is non-zero, the assembler will issue a warning statement for you. Finally, some of the other language extensions that we've provided. We now allow you to use predefined absolute symbols in a very large set of conditional assembly contexts. This gives you more symmetry between the conditional and the ordinary assembly languages. Another factor that is very useful when you're writing macros is that the assembler will now let you recognize substituted sublists with the same technology for inner macros as you can today use for outer macros. Today's assemblers make a distinction in that substituted sublists in inner macros have no structure, so that notations like ampersand sublist or list notation like the number attribute and so on do not recognize the structure of those inner macro operands. In this example, this list, if it is substituted into an inner macro call, will be recognized as old assemblers did, namely as a string of characters if you specify the compat option, or as a list structure as it was recognized in outer macros if you specify the no compat option. This means that you can write macros without having to be sensitive to whether they will be invoked as outer or inner macros. A number of other extensions include the fact that literals may now be used as terms in many more contexts than previously. The name field operand of a macro call need not be a valid symbol. The aread symbol, aread statement now allows you to specify two operands that will read the current clock either in binary or decimal. The aspace and aeject statements allow you to make your macro definitions more readable. And, for example, symbol attribute usage is now allowed in a much greater variety of contexts. In previous assemblers, only the length attribute could be used in both conditional assembly and ordinary assembly expressions, and now the type, scale, and integer attributes are also allowed in ordinary assembler statements. One of the language features that I will not describe in detail that is supported by the new high-level assembler is the addition of 19 new system variable symbols. These allow you to encode into your object deck information about the environment in which the assembly occurred, new date and time values, nesting levels, and so on. The details are described both in the presentation guide and in the product publications. The high-level assembler also includes a number of features that we believe will increase its usability, the readability of your code, and the accuracy of your programs. I've already mentioned the additional using diagnostics. Another feature that customers have found very nice is that you can request that at the top of every page there be a summary of all of the currently active using statements. This allows you to look on one page and see exactly what's going on in terms of address resolution on that page without having to read back in the program. There are many improved diagnostic messages. We try to give you much more information about a particular error condition than previous assemblers have. The messages may be selected by option to be in either mixed or uppercase. The terminal output has been simplified, and you now have two options for how that is produced. The underscore character is now allowed as an alphabetic character. This will help you to integrate the assembler, for example, into environments where other languages use external symbols in which the underscore character is used as a prefix. The conditional eject statement has an operand that specifies that if you are within this number of lines of the bottom of the page to do an eject, and this will allow you to build programs in such a way that they maintain their readability as they're enhanced. The heading date includes the century, so you'll now be able to tell what happens as you approach the year 2000. And finally, the location counter column heading indicates which kind of a control section you're in, ordinary, a dummy control section, or an RSECT. Some other usability features include extensions to the line count value. In particular, line count 0 will suppress page ejects so that small assemblies will appear on just 1 or 2 pages of paper. Listing control enhancements I won't describe in detail here. The options handling has been improved considerably so that the first page of the listing, as is done for most other high-level languages, tells you which options are in effect and what you've supplied. You may also fix certain options at assembly time so that they can't be overridden. But you can also, if you like, get a copy of the options control section and tailor those for your own use. You can specify at install time the PE stop option, which says that if there's an error in the parameters, suppress the assembly. This will help you to save resources that might otherwise be needed rerunning assemblies to correct parameter errors. The language option is what lets you select whether you use mixed case or uppercase messages, and the op table option lets you select a particular instruction set. In this case, there are 4 possible values: the 360 and 370 opcode tables, the XA, the ESA, and the universal opcode tables, the last of which is the union of the previous 3. The documentation has been considerably improved. We now have a new diagnosis guide. All of the publications have been completely and extensively overhauled, and we believe they're much more readable. There are a lot of new examples, and we've actually tested most of them. There are new sample programs, and there are mapping macros available for the SysA data records and for the IO exit work areas included with the sample programs. The new high-level assembler also has some new features in the way it is integrated with the other languages and systems. In particular, VSE ESA users will see major increments because the new assembler contains not only all of the functions of assembler H compared to the old DOS VSE assembler, but all of the advantages of the high-level assembler compared to assembler H. It is installable on all of those systems in shared storage, so that for shops that do a lot of assemblies, you can save some resources by sharing the assembler. The new assembler has improved memory management. It only uses the utility file when it needs to, as opposed to previous assemblers, which always used it. The operation code tables, the options and messages are loaded at invocation time, which means that you can now select which ones you want by option. The size option allows you to control the amount of storage that the assembler will obtain. The alias statement allows you to specify in the ESD, the external symbol dictionary for the assembler, that the name that is used internal to the program should be substituted with another character string. This allows you to interface the assembler to languages which use characters which are not a part of the assembler's base character set. On CMS, the interface module has been completely overhauled, and there are a couple of other factors as well. Some other enhancements worthy of note is that the internal structures of the new assembler have been considerably revised to improve its maintainability. QSAM is used for all of the non-utility files, which will mean that any improvements in the access methods will be automatically available to the assembler without recoding. The install process has been simplified and reorganized. The assembler produces, when it believes it's about to die, a more detailed suicide note. And in general, the performance of the assembler will be considerably improved over previous assemblers. For assemblies that contain ordinary quantities of macros, you will see improvements in processor time, elapsed time, and I/O counts on all systems. For assemblies which are built almost entirely out of macro calls, you will use more processor time on MVS and CMS, roughly the same elapsed time on those two systems, and improvements in I/O counts, with substantial improvements on VSE. We believe that this increase in processor time is a valid trade-off between the costs of people time, which have been increasing over the last years, versus processor time, the cost of which has been decreasing over the last several years. We have tried in the new high-level assembler to emphasize upward compatibility with existing programs. The compat option allows you to control the treatment of case sensitivity and substituted macro sublists if it is important for you to retain the behavior of previous assemblers. There are some previously undiagnosed situations which will be diagnosed by the new assembler, but we in general will give you options to control that flagging. The new assembler will require more storage. This may be a factor in the way you install it and use it. Generally, storage is much more easily available now than it was for previous assemblers. And we have not tried to list all of the extensions over the DOS VSE assembler because there are so many of them. So in summary, we believe that this presentation has demonstrated to you a lot of new technology for assemblers that will help you to support those critical applications, to maximize your productivity as a person with critical skills, and to help you to integrate this new assembler into the tools that you use. We've shown you a lot of new productivity and reliability features, including a lot of the language enhancements, the usability enhancements. We've shown you examples of some of the new diagnostics, and we believe that we've given you an indication of the improvements in almost every area. We hope that these will lead to cost savings for you through faster development cycles, that you will be able to produce more reliable applications that need less debugging, and finally, that you will be a more productive programmer and your management will be happier. So if you feel like an assembler programmer who is struggling to maintain a backlog of assembler applications using tired old assemblers, we believe that IBM has produced for you a solution that will give you greater speed, reliability, and power. And if you would like a copy of the assembler button, stay tuned and we'll tell you how to get one. Thanks for listening.